Welcome to API Kitchen, where we cook up secure APIs. I'm confident Stanley, your chef de cuisine in this unique kitchen. Now, you might be wondering, what's cooking? This first episode is all about API security and why it matters. APIs, or application programming interfaces, are like the waitstaff of the internet. They carry the orders from your device to the kitchen, where the data is prepared, and then they deliver the data right back to you. They are fundamental to how modern software communicates. APIs are the secret sauce that connects different systems, allowing them to share data and functionalities. When poorly managed, these APIs can be a gateway to data breaches, making the entire system vulnerable to attack. That's right, a cyber criminal could get access to sensitive information, tamper with data, disrupt services, or even gain unauthorized access to systems. The cost of these security breaches can be substantial, ranging from financial losses and regulatory fines to even reputational damage. Our main course for today will be the OWASP top 10 vulnerabilities for APIs. Consider this the most unwanted ingredient in your API kitchen. Number 1, broken object level authorization, or simply called BOLA. Picture this. You're running a bustling kitchen and you've got different pots on the stove, each with its own unique dish. Now, your assistant needs to stir the pot that he's assigned to, not the one you're working on, right? But imagine, if he could just pick up any spoon and stir any pot. That's a recipe for disaster, or don't you think? Similarly, in the realm of APIs, BOLA is like a chef assistant stirring a pot they shouldn't be able to. A user gains access to other users' resources by manipulating the IDs in the API endpoint. It's like tasting someone else's soup, or worse, adding unwanted ingredients. So always remember, in the API kitchen, keep an eye on your pots and who's stirring them. Number 2, broken authentication. This one is like a mixed-up seating arrangement in your restaurant. Let's say you have a VIP reservation, a seat specifically reserved for a specific person. What happens if anyone can just walk in and sit at the reserved spot? That would be one disgruntled VIP. In the world of APIs, broken authentication works much the same way. It's when unauthorized users can pretend to be someone they are not by exploiting poorly implemented authentication processes. So, like ensuring only the right people sit at the reserved table. You want to make sure your API recognizes and grants access only to valid users. Number 3, broken object property level authorization, or BPLA, like I like to call it. Now, imagine you're running a smoothie bar. Each customer can choose the specific ingredients they want in their smoothie, but then someone without permission starts adding or taking away ingredients from someone else's order. It's not just a ruined smoothie, it's a breach of trust. Similarly, in API land, BPLA is like meddling with someone else's smoothie order. A user shouldn't be able to manipulate the properties of an object that doesn't belong to them. Because, like a smoothie, each object in an API has its own specific ingredients or properties, and we need to ensure they stay as intended. No unexpected additions or removals. Number 4, unrestricted resource consumption. Imagine you're running a bakery and you're making your very famous apple pie, but then someone comes in and takes all your apples. Now, not only can't you bake any more pies, but your bakery's operations is also disrupted. Similarly, unrestricted resource consumption in API terms is like an overzealous customer hoarding all your apples. It's when a user or process uses up more resources than necessary, like memory, CPU, or bandwidth, and ends up affecting the performance for everyone else. Just like keeping an eye on your Apple inventory, it's vital to ensure your API resources are used judiciously. Number 5, broken function level authorization. Now, picture this. You're in a bustling kitchen, and your staff functioning as a dishwasher somehow ends up in the spotlight preparing the main course. As well-intentioned as they may be, they aren't authorized or equipped to handle such a task. Therein lies the chaos. In the cyber world, broken function level authorization happens when an API user gains access to functions beyond their kitchen station or role. It's like a dishwasher getting their hands on the pan when they should just stick to their soaps and sponge. So in our API kitchen, we need to make sure that each user only has the kitchen utensils or access rights appropriate for their role. In the coming episodes, we'll be discussing the remaining 5 vulnerabilities. Remember to subscribe to CCNet TV and hit the notification bell so you won't miss new episodes of API Kitchen showing each Thursday. Until then, keep your kitchen clean and your API secure.